For this video assignment, number 23, we're going to be looking at lesson 11.9, more power series. So in this section, we give series to various interesting numbers and functions using the following examples. So in example 1, we're looking at finding a power series representation for the function 1 over x plus 2. So we can write this out in the given form 1 over x plus 2 negative 1 to the nth power and x to the nth power. So then we're going to want to put it in correct form. 1 over x plus 2 is equal to 1 over 2, or 1/2, and 1 over x over 2 plus 1, which can be plugged into the form and simplified as 1 over 2, or 1/2 once again, n equals 0, negative 1 to the nth power, x over 2 to the nth power, which is equal to the summation of negative 1 to the nth power, x to the nth power, all over 2, n plus 1. And this would be our final answer for the power series of 1 over x plus 2. If we go to our second problem, true or false, we cannot find a power series representation for a tangent or arctangent of x, because arctangent of x is, and this is the integral that it states, dx has infinitely many terms inside the integral. And if we're solving this, we're going to say that this is false, actually. And we can prove this with the integral of 1 over 1 plus x squared dx is equal to the arctan of x plus c. Remember that arctan of x is equal to tangent of x. These mean the same thing. So we look at 1 over 1 plus x is equal to summation of n equals 0, negative 1 to the nth, x to the nth, so if we write all of this out, x squared to the nth, then we can write and continue down here that the arctangent is equal to the integral of summation n equals 0, negative 1 to the nth, x to the 2nth dx plus c, which is the constant here. And continuing down here, we will write that n is equal to 0 of negative 1 to the nth power x to the 2n plus 1 power all over 2n plus 1 plus c. Then again here, the constant. When x is equal to 0, c is also equal to 0, so here and here. So we will write that the summation of n equal to 0 of negative 1 to the nth x to 2n plus 1 all over 2n plus 1, and this is our final answer after looking back at our true and false problem, that it is false, that we can actually find a power series for the arctangent of x.